Lesson 9.1, apply the inverse and combined inverse and combined variations. You have done direct variations many times. Direct variations, this is just review, but direct variations are of the form y is equal to k. Y is equal to the form kx, okay? And so, in a direct variation, the y-intercept is where? The origin. That's correct. It's at the origin. This looks the same as y equals mx plus b, except b is 0. It's not there. Right? So that's the direct variation.
Why is the K capital?
That's not.
Oh.
It may look bigger, but it's not. It doesn't matter either way. K just represents a constant. Okay? Well, today we're going to talk about inverse variation. An inverse variation is always of this form. Y is equal to k over x. Y is equal to k over x.
Or X not equals K.
What's that?
I was reading from the book.
So, would the y-intercept be separate of the fraction? Would it be like k over x must be like the quotient of k over x must be, or would it be on the denominator of x?
Say that one more time. Ask that question again. I'm sorry.
Okay, so
I had something else in my head and I didn't clear it quick enough.
Okay, where can y-intercepts appear on this? Or like would it
Can
be,
y-intercepts appear on this?
like would it be separate from the division? Would it be the quotient of k divided by x plus 3, or would it be in the denominator?
No. You're right. Will not have a y-intercept on this. Because x can't be,
Yeah.
x cannot be 0 in this case, right? So it's not going to give us right. Now we are going to go beyond this later on in the chapter, and we're going to just talk about rational expressions. Rational, remember, can be written as a fraction. That's basically what rational means. And so we're going to talk about expressions with variables that are in fraction form. And so our variables might be in the denominator, and we're going to talk about graphing them. We're going to do a lot of that kind of stuff. And that's kind of why we wanted to look at that little project we did yesterday and earlier today. All right, so this is our inverse variation. Okay? Our joint variation looks like this. Y is equal to k times xz. Okay? X and z are our two variables now, and they're both direct. They're both are in the numerator, aren't they? The x and the z are both in the numerator. So that is a joint variation when you have more than one in the numerator.
So will that cross the y-axis?
Yep.
Yeah.
Because now x can be 0, can it?
Yeah.
Yeah. I don't think, to be honest, we're going to look at graphs of joint variations, because I think we'd have to take them apart, because we can only right now look at graphs of two variables, right? The x and the y, and now we're throwing in some z, which is a variable also. And so we'd have to use a three-dimensional graph, which isn't where we're going to go. Okay? And we could have more variables in our equation. So we might have to, if we wanted to graph them, we would just have to isolate one of the variables and draw a graph and just show this is a relationship just between these two. And then show a graph of this is the relationship between these two variables. And we're not going to do any of that. Okay? And then the last one is combined. And a combined variation is going to look like this. We're going to mix, in a combined variation, we're going to mix a direct variation with an inverse variation. All right? We're going to mix them up. So if they say they want you to write a model, find the equation that models the situation, and they use the word jointly, then you're going to be looking at something like this. It might be different letters. It might be pressure and temperature and volume and all that kind of stuff. Okay? But you're going to look at something like that. If they use combined, then you're going to be looking at something that has direct and inverse. And they may not say combined. It might say something varies directly with whatever and inversely with something else. Okay? And they might have them in terms that make sense in a story. Sorry, I paused that so I could get my mind clear. So we're talking about the volume of a gas. And we just said that the volume varies directly with the pressure and inversely with the temperature. And that, again, was because as the temperature drops, you're allowed to have more gas in your container. Okay? But as the pressure increases, you get more and more gas. So as the pressure goes up, you get more and more volume. As the temperature goes up, you get less and less volume. Okay? All right. So here are some direct, inverse, joint, and combined variation models. And they're going to ask you a bunch of questions about these today. Let me see where I'm at. I covered them all. All right? Pause this for a second now.
Because I'm probably not going to change it until next week.
Why are you recording this?
Because people like you.
So people that aren't here will know the assignment. There's the assignment.